Good day, everyone. So let's check your assignment. Our number 1, the quarterback throws a football with an initial velocity of 25 meters per second. And then given that the initial angle is 55 degrees. If you are the receiver, so we have to estimate how long and far it takes to run and catch the ball. Now, before we solve this, let's get the given class. So we have the given. In this case, we have our initial velocity as 25 meters per second, and then the initial angle is 55 degrees. In order for us to get the time, in this case we have our time is equal to initial velocity in y component over the 0.5 gravity, right? But since we don't have our initial velocity in y component answer, we can just simply change that. Let's change this. It becomes initial velocity in multiplied by the sine theta. Okay, so we use that one instead. Now you already know that is a 3-point formula. Okay, so a 3-point formula, and then substitute your initial velocity with 25 meters per second multiplied by our sine, and that is 55 degrees all over. So let me just erase the side, okay, because we have to put it here instead. Now 0.5, then you already know that the gravity is 9.8 meters per second squared. 25 sine 55 degrees, we got 20.4788011. Then do not forget we still have the meter per second. Then all over by, and you already know a 9.8 is just half of 4.9 meter per second squared. Here, we can get the quotient of 820, 20.4788011 divided by the 4.9, in which we got 4.179347165. And remember, we have the meter per second in numerator, and then the denominator is meter per second squared. So cancel it out, this one, and we only have our second here. Then approximately round to the nearest hundreds, then we come up with 4.18 second. So that is our total time. Okay, now let's proceed by our how far. So we already need this one, how far, and remember that is a 4.18 seconds. Now getting our that one, erase this. Remember, it is the final position, because when you say how far, if this is our point here and throws it like this, going by our final position, it means this side, right? How far? Then again, that is our x-axis. Now we have our initial velocity in x component multiplied by the time. If we have our sign for the y component, then it means getting that one. Now let's change this instead. Replace this. Initial velocity cosine theta multiplied by our time. Now our initial velocity is still the same as 25 meter per second. The cosine 55 degrees. Now our time here is 4.18 seconds. Okay, now the 25 cosine 55 14.33941091, and we still have this meter per second, and do not forget we still have our 4.18 second. Now take a look at this one. The first part is on the denominator while this one is on the numerator. Y second over 1. Okay, which means we just simply cancel it out, right? Then get the product. So it's a 4.18. That is your x, or the range we got here, 59.937376, and as you can see we have our meter. Now that is exactly our total range, and by round it off to the nearest hundreds, so round to the nearest hundreds, that is approximately to 59.94 meter. Okay, so that is our total range. Now let's proceed in number 2. So this time our given, so our initial velocity 30 meter per second. The initial angle is 35 degrees. It says here that we have to get the maximum height, right? Now remember, if this is the cliff, okay, so ang kasagutan na class, this is the person kicking the ball, okay, nasa diri side, so kicking it, that one. So let's proceed here, which means the need here, we just simply need to get this maximum height. Now remember class, getting our total time starting from here to the final position of the ball, getting the total time, we have this, right? The initial velocity in y component all over by 0.5 gravity, right? Since we only need the maximum height, so it means we need the time duration happened here. Yan siya. Okay? Again, since that is a maximum height, it means ang time duration that happened here. Now, how do we get that one? As you can see, we try to draw this as this. Okay, now take a look at this one. In this case, you can see that in order for us to come up with this, it is just a half of this, right? Then, by getting that one, diba, we can also write it down. Diba, it really means that this one is an initial velocity in y component all over by the 0.5 in fraction, that is only a 1/2, right? So that is a 1/2 of the gravity. So, mana yan dagway. Then this time, remember, initial velocity can be written like this. All over by 1. Okay? So, it really means initial velocity over 1 is just being divided by, now gravity is on the numerator. So, we just simply change that into like a gravity over 2. Because there is 1 here para sa 1/2 na to. Which means that is a gravity over the 2. Just have our initial velocity in y over 1. Then change your division into multiplication. Since you change that, we have the reciprocal. Okay? So we got here as 2 over the gravity. Our total time can be also written as like this. Initial velocity y multiplied by the 2 is 2. Inertial velocity in y component. 1 times the gravity is just the gravity. That's why you can really choose any of the two. Why do we need this one? Para masaktan ninyo, how do we come up with our time at the top? In order for us to get this, diba, it's just the half of this, kung ato na i-drawing, which means we just simply divide this one into half. Okay? So, by that, now remember, in this case, the t, there is 1 times c over 2, right? So 1 t over 2. Okay? So it means here, it is the half of your total time. So, instead of writing the t over 2, we just simply put like this. T for the time at the top. Okay? So t sub top. You divide both sides by 2, it means we can cancel this side. Which means, in this case, ang mabili na lang natin is the initial velocity in y component by the gravity. So this is our new formula. This one. But since we don't have our y component pa, which means we just simply change that into initial velocity multiplied by the sine theta all over by gravity. So that is our new formula. Now let's proceed. Substitute our initial velocity, that is 30 meter per second, multiplied by our sine theta, that is 35 degrees, all over by our gravity as 9.8 meter per second squared. 30 meter per second multiplied by our sine, 35 degrees, that is 17.729309 meter per second, all over by 9.8 meter per second squared. We come up with the quotient as 1.755846.234. Okay, so we just simply cancel it out. That is the second. So reaching the ball at maximum point, maximum height, or the time at the top, we get like this. I'm sorry, we have to get the sorry, let's go back. time at the top, it is 1.7555846234 seconds. Then approximately 1.76 seconds. So that's for the time at the top. Now getting the maximum height, we have to use this formula. Why? Again, maximum height man atong giisgutan, it means the time at the top. We really need the time at the top man jud ani. Diba, in order for us to get the final position in y component, we need y equals to initial velocity in y component multiplied by the time minus 1/2 gt squared. It's really important for our time plus. Let me erase this one. This is for all man, because this one you can just simply get the answer because we already have the top, right? The time at the top. But in order for us to get an exact height for that, we need this. Okay, so getting the formula, replace your time with the formula in the time at the top. So this is, of course, y equals, now, para mas dali niyo masabtan, since maximum height man na siya, let's change our y name into a capital H. Okay, now let's go back here. Initial velocity in y, and then the time by the formula. So ganito, it is initial velocity in y over the gravity, right? Then next, that is minus 1/2 g multiplied by, since that is t squared, it means initial velocity in y component over the graph is this one. In this certain part, initial velocity y can be written as over 1 because that is a whole number. Okay, which means you just simply multiply this with this one. So here, let's change this. Okay. That becomes 2 initial velocity in y component, so it means square. Okay, it has been multiplied by 2 or twice, then all over by the gravity minus, you have here as the 1/2, still a gravity. Gravity can be also written like this. Your initial velocity needed by square this one, and also your gravity, you square that one. Okay, and then we cancel this one. Getting that one is initial velocity in y component squared all over by the gravity minus, that becomes initial velocity in y component squared all over 2g. Now this time, the LCM for that, or the least common multiple in the denominator, is just 2g. So gravity or g divided by the 2g, we only have 2. That's why 2 times like this class, para masabtan ninyo, 2g, you divide this, okay, 2g divide this. So, di ba mabili na lang is the 2, kaya makancel man. Then, i-multiply ni mo sa kani. So, it means 2 multiplied by this. So, that's why if we write it down, it's like this. Like this one. Okay, still maximum height. Now, 2G is just the same as what we did. It becomes 1, right? So multiply by this, we only have initial velocity in y squared. Now, in this case, we come up with this same unit. So there is 1 here, there is 1. So it's just 2 minus 1. And 2 minus 1 is just 1. Then it means 1 times here. We can just simply write it down as v. Initial velocity in y squared over by 2g. That is your maximum height. Since we already have our formula, 30 sine 35, it is a 17.2709 meter per second. Since that is square, you square this one. Para mas dali sa ninyo class, I'm gonna write it down na suppose how we don't get our time pa. Sag-asa man dyan magsugod ka kung ating gusto. As long as nakakuha mo sa flow niya. Now, diba initial velocity ng y component is just initial velocity sine theta. Correct? Let's see sa squared. Square that one. All over by or 2 times the gravity. Next, initial velocity, ako lang po kang balik ha, na suppose wala ng time ng ipangayo. Okay, we only have the maximum height. Then 30 meter per second multiplied by our sine 35 degrees. And we can just simply put like this instead. That is squared. Ulit. So again, 9.8 meter per second squared. Put it here instead. Again, 30 sine 35 is 17.20, diba? Parihara. 309 meter per second. But remember, we still have to square that one. Then that is 9, I'm sorry. That is 19.6 meter per second squared. Then we square the numerator. Let's square the numerator. 296.0909355. Then remember that is meter squared per second squared. All over by that is 19.6 meter per second squared. Then let's get the quotient. That's divided by the 19.6. We come up with 15.10668038 meter. That is meter. That's maximum height. Why? Because we cancel this, then eliminate this one and this one. That's why we have our meter. That is round to the nearest hundreds. That becomes 15 or approximately to 15.11 meter. Now remember, your maximum height has been based. Remember, your maximum height should be based with the cliff, right? Cliff na amatay 50 meter already. Then, if naani siya nga part, kung nakik ng bola from this to the ground, the maximum height is this one. Then, ang pasabot niya ang maximum height ni iyang gikuha is just here. Kaya naman, to make sure we can have the half of that, the time at the top, right? Mawat itong drawing. So, we need here. So, ang kanang 15.11 is here pa na. Okay? Therefore, the total maximum height is just simply added with 50 meter. Okay, that's why the maximum height, really the total maximum height is what? 65.11 meter. That's the final answer. Okay, now let's proceed in number 3. So a cannonball is fired with an initial speed of 250 meter per second and the initial angle is 45 degrees. So calculate the final velocity and its position 10 seconds after. We have to write or given. Given that your initial velocity is 250 meter per second, initial angle is 45 degrees. Now, we already have our given time, 10 seconds. You can just simply use the final velocity as initial velocity in x component, right? The initial velocity in x component, since we don't have our answer for that path, we just simply write it down as initial velocity in cosine theta. So initial velocity is 250 meter per second multiplied by our cosine 45 degrees. So it's 250 multiplied by cosine 45. 176.7766953 meter per second. That is the final velocity in x component. Now proceed to final velocity in y component, in which our formula is initial velocity in y component minus the gravity time. And it's just the same since we don't have our given. We don't have our calculation for the initial velocity y component. So we simply write it down initial velocity multiplied by the sine theta, then minus with the gravity time. Okay, the initial velocities is 250 meter per second times the sine 45 degrees minus a 9.8 meter per second squared. Then the time is 10 seconds. So do not forget there is an equal sign. We have our 45 degrees as the initial angle, 45 degrees, and you already know that's the half of the 90. And half of the 90, it means only can be the same value, right? It's just that we should know at what quadrant. For 45 degrees is on the quadrant 1. Quadrant 1 means your x and y are both positive, which means you just simply copy this one, 250 multiplied by the sine 45. Even though you try to compute that, it's just the same, 176.7766953. Then that's the time you multiply by our 9.8 by 10, and just you simply move it to the right once because there is only 1 0. So once, so you have your as 98 meter, and you eliminate this. That's why you only have meter per second. Okay, I'm sorry, I forgot to write down meter per second here because we don't forget later, right? Okay, now we get the difference. So it's 176.7766953 minus the 98. So the final velocity in y component 78.7766953 meter per second, and that is approximately to 78.78 meter per second. I'm really sorry if I did not get the approximate of the final velocity in x component. So let me write it here na lang. Final velocity in x, that becomes 176 point, approximately to 176.78, okay? Meter per second. Final velocity, we just simply have final velocity next component squared plus final velocity in y component squared. Final velocity next is 176.78 meter per second. And then multiplied by our final velocity in 78.78 meter per second. So please bear with me kung saba kayo ha. So it becomes 176.78 squared is 1. Then 31251.1684 meters squared per second squared plus
Make sure at the back
6206.288 4 meters squared per second squared. And remember that is square root, no? So we add that one. So it becomes 37457.4568 meters squared per second squared. Now, do not forget we still have to square root, right? The square root that one. That becomes our final velocity as 193.5392901. And do not forget, eliminate this for our meter squared per second squared. That's why we only have meter per second. That is approximately to your final velocity is 193.54 meter per second. So that is the final velocity at 10 seconds. Let's proceed by getting our position. Okay, so let's get the position, class. Proceed to compute our final position in x component. Initial velocity at x component multiplied by the time, correct? Now remember, since we already have our initial velocity in x, then we can still come up with just getting that kind of formula, right? 176.7766953 meter per second, then multiplied by our time as 10 seconds. Then we cancel it out. Then our x is, you just simply move it to the right once. That's why we come up with 176.766,953. Okay, so we have here our meter. It means approximately that is 1,767.77 meter. That's the position in x-axis. Now in Ry, we come up with initial velocity in y component multiplied by that time minus a 1/2 gt squared, which means we could just simply write it down as 0.5 gravity times squared, correct? We can do that. We can do that, huh? Initial velocity, it means just the same. That is 176.7766953 meter per second multiplied by our time, 10 seconds, then minus with our 0.5 gravity. Okay, sorry, the gravity here. That is 9.8 meter per second squared multiplied by our time. Time here is, okay, let me write it down like this para di malipat. 10 second, tapos you square that. Okay, then the same as this one, it's 1767.766,953, and we cancel this, that is meter. Okay, minus half of 9.8 is just 4.9, correct? That is 4.9 meter per second squared. Okay, then the 10 second square that one we have here as 100 seconds squared. Now we can cancel this out, right? That's why since we have two decimals for 4.9, that becomes, let me write it down here. Ako na lang yung isa, kailangan naman tayo. Okay, now this becomes as 1767.766, sorry, 953 meter minus, that is 490 meter. Why? We move to the right twice. Okay, we have two zeros, right? 767.766953 minus 490. That is our y. 1277.766,953 meter, which means it is our y position is approximately to 1,277.77 meter. So if we try to plot that one in our x and y, then we can write it down as 1767.77 meter, and our y is 1277.77 meter. So far, this is the far, high. Okay, so x, far, y, high. That's it. Okay, so that's how you solve the three problems. Okay, thank you so much, class. We will just continue our discussion by next meeting. Goodbye, everyone.